8. What are we asked to do in number 6, 7, 8? Very good. In number 8, we have log base 4 of the 7th root of a to the 6th, b minus 1 to the 3rd over 16. We have to start with the 7th root, which is the same with power. 1/7. So 1/7 goes in front, log base 4, a to the 6th, b minus 1 to the 3rd divided by 16. Do we all agree with this step? The 7th root is power 1/7. That's why we put 1/7 in front. Is that okay? Yes, everyone? Okay, perfect. Then, remember this stays outside, and we put a bracket. Remember what we said. If the quantity is coming from the top, it will have positive in front. If the quantity is coming from the denominator, it will have negative in front. And there is only one quantity coming from the denominator. Put the exponent in front. Very good. Also replace this by what? 4 raised to which power is 16? 2. So this is 2. So this is 1/7 with 6 in front. 6 over 7 log base 4 of a. I brought 6 in front, and at the same time I multiply by 1/7. Plus, I brought 3 in front, and I multiply by 1/7. Log base 4 of b minus 1. And minus 2, but also multiplied by 1/7, I had to multiply all terms by 1/7. And this is absolutely final. No one can further expand this expression.
So I have a question.
Yes.
I kind of did it a little differently, but I don't know if you can look. I mean,
Yes, of course. Yes. So you did it in more steps than this.
Maybe because I did it all over 7, but I don't know. So
That's fine too.
So
That's
this
perfect.
is correct. Okay.
Yeah.
That's why I got confused
Yeah.
because I saw.
Yeah, I put it 1/7. I said, wait for me. Let me finish the inside, and then I distributed.
Okay.
You wrote it over 7 from the very beginning, which is fine.
Okay.
But
I think that's 3 because you know it's 3. Yes, because I.
Yeah, but you have to bring the 3 in front. You have to
Yes.
bring the 6 in front, and you have to change this into 2. So this is 2/7.
Okay.
So I think it's more work if you include, because now the complicated part is if you have a long fraction.
Yes.
And it's a little bit more complicated. It's not wrong. Everything you did is perfect. But if you leave this 1/7 to work with it at the end, just keep it in front, finish everything inside, and then distribute 1/7.
Okay.
Or you can write everything over 7, but it's better not to. It's not wrong. It's 100%. Very good. Next question, anything you want. Anything you would like to work on?
Maybe 14.
Yes, of course. 14. Yes, perfect. So we are given a logistic growth model. F of time, I guess, is 110,000 divided by 1 plus 5,400 e to negative t. Perfect. Describes the number of people, f of t. So this is number of people. We may have done this problem in class. Who became ill with the flu t weeks after its initial outbreak in a particular community. So t in weeks. So it's time in weeks. How many people became ill with the flu when the epidemic began? So how many people were ill by the end of the 4th week? And then what is the limiting size of the population? These are all the questions. Okay? So first question, how many were ill initially? And then how many people were ill by the end of the 4th week? So I have to find what first? F of 0, very good. And in part B, F of 4. Of course, every time I have more than one number to plug in, I highly recommend put the function in. So in y equals, clear what you had before, but be careful how you put it in. The numerator is just one number. It can be used with put parentheses around or not. It will work either way. But the denominator is a big issue. We have to put parentheses around the denominator. So I have 1 plus 5,400 times e, and in parentheses, please parentheses for the power, especially it starts with negative. So negative x, close the parenthesis for the power, come down and close the parenthesis for the denominator. And now we go to second and table, and we plug in 0, and then we plug in, what did we say, 4. So initially, do not round up people, right? So it's 20 people initially. And then 1101. Yes, Danny?
No, I just stretching.
You're okay. So this is what I recommend. Writing 20 people and 1101. What is the limiting size of the population? So the function comes in handy because now I go back to the function and I say to myself, okay, 0 weeks, 4 weeks. Okay, now I want 40 weeks. And then I want 50 weeks. And then I want 100 weeks. Which means as time goes by, what do I get?
Population size.
Yes, the total population of the community, assuming, of course, there is an assumption here. What is the assumption? Nobody's visiting, right? And nobody leaves the community. So then F goes to 110,000 as t approaches infinity. And what does this mean? We've seen this in chapter 3, that when t or x increases without bound or decreases without bound, oops, I'm sorry. So as t increases without bound, t approaches, the function approaches 110,000 people. So what does this mean? And we've seen this in chapter 3. As time or x increases without bound, either to positive infinity or negative infinity, if the function approaches a number, what does that mean for the function? Horizontal asymptote, right? So then y equals 110,000 horizontal asymptote at infinity only. We're not talking about negative time, so we can even look at the other direction. Anything else?
No, but on number 15, I don't know if I just.
Let's work on it. Any problem?
I got confused because it was talking about a figure and radius, and I
Oh.
misread it.
Yeah,
Oh.
15 doesn't apply.
Yeah, as I mentioned to a previous class, what happens when I sometimes, not always, when I send to the copy center to print out something, if it's in PDF file, somehow some graphs disappear. I don't understand why. Shows the graphs of the cost and revenue functions of a company that manufactures and sells small. How many radios must be produced and sold for the company to break even? Okay. So let's go to our book. And let's see. This is under systems. We'll find a problem in a blink. I did already on page 556. And here's the problem. Problem 55. I copied it from my math lab. 55 on page 556. And here's the function. Here are the functions. Okay. So we are given the cost in blue, and we are given the revenue in purple, and we're asked to find the break-even point. When do we get the break-even point? When the cost and the revenue offset each other, right? The profit is zero. So it's right here, this point. Yeah, from here I can read it, but I'm not asked to read it from the graph. I'm asked to find it. So I'm going to copy the two functions. And here's the revenue, 50x. And the cost, C of x, equals 10,000 plus 30x. And this is our system of two linear equations in two variables from 5.1. And we're asked to find the break-even point, meaning when 50x equals 10,000 plus 30x. I move 30 to the other side, I get 20x equals 10,000. So then x must be 500. I'm asked to find the break-even point, which means x equals 500. How do I get the y? Always remember this is the revenue of 500. It doesn't matter. It will also equal the cost of 500 because I set them equal to each other. So when I plug in 500 here, this side must equal this side. But 500, I have 25,000. So the break-even point is 500, comma, 25,000. And that was 15, and my apologies, the graph didn't show. Very good. Next question.
You can plug in that 500 in either one of those equations.
They are equal.
Yeah. Right?
It doesn't matter. Yep.
Okay.
Because we got the 500 by setting them equal to each other.
Yeah.
So they must be the same. Yeah. Very good.
Can we do number 5?
Number 5 it is. Very good. So here we're given two. Yeah, in this one, the graph disappeared, and I'll tell you which function, which problem this is. So this is from 4.1. From 4.1, problem 75. 75 on page 476. 476, yes. Okay. So we're given f of x, 6.19 times 1.029 raised to the x, and we are given g of x, 37.3 divided by 1 plus 6.1 e to negative 0.052x. And we are told the bar graph, which is not there, shows a percentage of people 25 years of age and older who were college grads in a certain state for 7 selected years. The functions below model the percentage of college graduates among people ages 25 and older, f of x and g of x, x years since 1950. So when I read that, I also make myself a note that x equals 0 represents 1950. Which function is a better model? We can compare because we don't have the graph, but I'll show you the graph in the book. And but we are told to find the number of college grads 25 and older in 1980. What does that mean, and what am I asked to find? So obviously I'm asked to find f. Yes, indeed. So I'm asked to find f of 30, and I'm asked to find g of 30. I will not put them as functions in the graphing calculator because I only have to plug in one value for each. So I will just type them in. 6.19 in parentheses, 1.029, close the parenthesis, caret, I always put in parentheses, although the sophisticated calculators, I've said it many times, may not need this. And the second one is very careful. It's 37.3 at the top divided by, in parentheses, 1 plus 6.1 e in parentheses for the power, careful, negative 0.052 times 30, close the parenthesis for the power and come down and close the parenthesis for the denominator. And we get 16.334 or 14.59. But now I have to go back and compare. And here is, oops, and here is, so for 1980, the bar graph gives us 17%. So the two answers we got, and I'm going to copy them in a second. I will write for the first one 14.59%, and for the second one is 16.35%. So again, we are comparing the two models only for 1980. It doesn't mean that the second one will be better for all years, but obviously the second one is closer to 17%, the actual value, the actual percent, than the first one. So I'm going to say that this is a better model. But I will put better for 1980. I don't know. I haven't checked the other ones. So I cannot conclude that in general, this is a better model. Any questions? Okay. Is this better? Good. Next question. Anything you would like to continue with?
Number 6.
Number
Sorry,
6.
Number 9.
Number 9. Very good. Number 9. Use properties of log to condense. So let's condense. So in number 9 we have 3 log 2x plus 1 minus 4 log x. See you Wednesday. Okay. You forgot your
Ella?
That-
Yeah. I know she got her cup right next to it, so I don't think it was hers. Did you have her found her?
Okay.
Oh, the other girl works for the post office, doesn't she?
Very good. So then, how do I condense this? What do I have to deal with first? That's very important. What is the first step here?
What's in parentheses?
I can never touch that. Log applied to a sum, it's fixed.
Is the power?
The power. Yes, so this is log 2x plus 1 to the third minus log x to the fourth. Perfect. And now one is positive, one is negative. So what can it be? Hello. Was that yours? Did you forget that? Or somebody else?
No, it's not mine.
Okay, good. I'm glad you're back, Priscilla. Okay, so this is definitely log 2x plus 1 to the third over x to the fourth. Not over. It's not log of that over log of x. So be very careful. This is the property.
Can we also do number 10?
Of course, anyone. Any. We have to finish. I want to finish all of them. If not tonight, definitely on Wednesday. And I would like to start reviewing for the final.
On Wednesday?
Yes, when we finish with this.
Are we taking our test Wednesday or?
No,
Monday?
the test is next Monday. The test is a week from today.
Okay.
Okay, I'm sorry, which one was
Number 10.
number 10? Very good. So let's look at number 10.
I know we for sure went over this in class, but I went through the videos and everything and I couldn't find it.
That's fine. That's fine.
I think I missed
So no, 9x x plus 6 equals 81 raised to x minus 8. Good. Now, I can always apply log to both sides and I'm done. But this is easier than that because I see the left-hand side and the right-hand side can be presented with the same base. You can present the left-hand side as 3 squared and the right-hand side as 3 to the fourth because this is 9 and this is 81. You can also say, what about if I present the left-hand side with 9, leave it alone, and then change 81 into 9 squared? That works as well. Normally, we like prime numbers, but 9 works as well, so it's up to you. Now, it's easier if I just change only one of them, not both, right? So this is 9 raised to x plus 6, and this is 9 squared raised to x minus 8. Instead of changing both into base 3. Both are fine.
So can you write, because I wrote it as 9.
2x plus 6 equals 9 raised to 2x minus 16.
Yeah, okay.
Okay, so now remember, two numbers are equal, and they have the same base. What has to happen? Right. There is no other way. X plus 6 must equal 2x minus 16. If you had applied natural log from both sides, to both sides from the very beginning, you would have gotten the same answer. Okay? But you may introduce approximations, and I recommend this, right? I move to x and I move 6. So this is negative x, and this is negative 22, so x equals 22.
So the 9's cancel out.
That's what I said. We do not do any of that. Two numbers are equal, and they have the same base. What has to happen to their exponents? They have to equal each other. We're not canceling, we're not simplifying, we're not touching the 9. We're only thinking.
That's what I just bring down.
You are bringing down the powers if you apply natural log, not if you think in this way. Two numbers are equal and they have the same base. Therefore, the exponents must be the same. We're not bringing the power down, we're just thinking. Now, you are bringing the power down if you apply natural log, but we're not applying natural log. So we just say two numbers are equal and they have the same base. Therefore, the exponents must be the same. Any questions on this?
To get rid of the negative, we divide by -1.
Yes, or multiply by -1. Yeah, to get rid of a negative coefficient, you either multiply or divide. It's the same thing. It's the same thing, yeah. Just for -1, not for -2 or -4 or 4. But for -1, multiplication or division mean the same thing. Give us the same result.
For number 11,
Yes?
would we just punch that into the calculator?
Let me take a look. Yes, but that's you're for the final answer, but not from the very beginning. E to 11x minus 5 minus 3 equals 28498. First, you have to add 3 to both sides. You get 2, so this is 3, so it's 1 and 0 and 5 and 8. Now you apply natural log. You bring the power in front, 11x minus 5. How much is natural log E? Perfect. Natural log 28501. And now I have to add 5 and divide by 11. So x will be 5 plus natural log 28501 over 11. I'm adding 5 and I'm dividing by 11. I add 5 and divide by 11. Now this I have to put in the graphing calculator. So let's do that. Don't forget parentheses around the top. So 5 plus natural log 28501. 28501. Close the parenthesis. For the log, close the parenthesis for the numerator, and divide the whole thing by 11. And press enter. And the answer is 1.39. X approximately 1.39. I would not determine this number unless I'm asked to approximate. If I'm asked to leave the exact answer, I will not even bother with this. I will determine this number if I wanted to check the answer, of course. So I will put it in 11 times x minus 5 minus 3 minus this. So if you want me, I can show that too. But otherwise, I will not approximate. Now, if I'm telling you how much money I have in my pocket, I will not tell you I have 5 plus natural log of 20,501 divided by 11. I will have to say I have $1.39. I will not put the burden on you to calculate. So I will get an approximation. But other than that, I will always leave it as a exact answer.
Can we do number 8?
Of course. Number 8. 7, 8. Yes. We just did number 8. Let's walk through it one more time. So here it was. So first what we did, we identified the fact that the seventh root is power 1/7. So we took the power in front. So the seventh root of x is x to 1/7, and that's why this power went in front as a factor. Then we copied log base 4 of a to the 6 b minus 1 cubed over 16. And then we open brackets because I want to distribute this at the very end. So I have log of a to the 6th plus log of b minus 1 to the 3rd and minus log in the denominator. Why? Because the quantities that come from the numerator will always have positive in front. The quantity that comes from the denominator will always have minus in front of the log. So once I have this and plus of this and then minus of 16, then I bring 6 in front, I bring 3 in front, and this changes from log base 4 of 16 is what? 4, exactly. 4 raised to which power is 16?
2.
So that's why it changes into 2. So now 6 in front multiplied by 1/7 is 6/7. 3 in front multiplied by 1/7 is 3/7. And then 2 multiplied by 1/7 is negative 2/7. Is this good enough? Should I give it to you so you can? Of course, of course.
Can we go over -7 really quick?
Yes, yes, of course. So we want to continue with 7? You said?
Yeah.
7. The percentage, okay, very good. So f of x, 62 plus 35 log. I don't see the base of the log. What is the base here? Very good, awesome. So the percentage of adult height percentage attained by girls who are X years old. So they came up with a formula and they said, okay, if you're 8 years old and you're this height, then this number is a certain percentage of how tall you can be throughout your life. So that's what the formula is giving us. So it says the percentage of adult height attained by girls who are X years old can be modeled by this function, where X represents the girl's age between 5 and 15, and f of X represents the percentage of her adult height. Use this function to determine approximately what percentage of her adult height girls are at age 14. What do I have to do?
14.
Exactly. 62 plus 35. And how much is log 14 minus 4, which is 10? How much is this? Thank you, Cece.
1.
Exactly. That is 1. So then what is the percentage? The percentage is 97%. So it appears, according to the model, if the model is true, still, right, that when a girl reaches, according to the model, reaches the age of 14, she is, from the total possible height that she can ever get to, already 97%. So she will be by 3% higher than where she is at 14, not more, according to the model. Any questions? That's all we needed to do. Next question, please.
Number 12.
Number 12. Let's look at number 12. Very good pick. So log base 2 of x plus 6 plus log base 2 of x plus 5 equals 1. Good pick.
Oh wait, don't you just set x plus 6 and x plus
So I have to write that x plus 6 must be greater than 0.
Okay.
I have to write that x plus 5 must be greater than 0. And I have to find the common domain here. So this is greater than negative 6 and this is greater than negative 5. What will be the common domain? Yes, right? Because negative 6 to your right and negative 5 to your right, the common domain will be negative 5 to infinity. Is that better? Is that clear?
Yeah.
So here's negative 6 to infinity, and here is negative 5 to infinity. And they overlap only between negative 5 and infinity. Good. So now I have to condense this. It's a log equation. I have to condense the left-hand side. So how do I write the condensed form? Log base 2 of multiplication. Very good. And now the equivalency. Always remember we start from the base and go counterclockwise. 2 raised to the first equals that. 2 raised to 1 equals that. So 2 must equal, and I multiply, x squared plus 5x plus 6x is plus 11x and plus 30. So then I have x squared plus 11x plus 28 because I have to subtract equals 0. And I'm hoping that I can factor. So how do I factor this? Yes, so I factor into x plus.
X plus 7 and x plus
Very good. And I have two options. But remember, you can't trust it. You have to go back. That's why we put the effort in to find the common domain. So what do you conclude?
x equals -1.
-9 is outside of the domain. It can never be accepted.